Alright, first one, we're finding the limit as x approaches -2. So the first thing I want to check is plug in -2. If you do that, you get 0 over 0, which means indeterminate. This means I need to mess with this. So I'm looking, looks like I can factor out a -3, and that would give me x plus 2. Factor out the bottom, that would be x plus 2 and x minus 1. X plus 2 is going to cancel out. And now I can plug in -2 here. That's -3 over -2 minus 1. That's -3 over -3, which is positive 1. Here, u is x, u prime would be 1, v is natural log of x, v prime would just be 1 over x. I'm using product rules, so that would be u prime v plus u v prime. U prime is 1, v is natural log of x, plus u is x, v prime is 1 over x. So this is just natural log of x over x is just 1. Natural log of x plus 1. This I'm going to rewrite as sine of 5x. All of that is getting cubed. So this is chain rule. I've got functions inside of functions. I actually have 3 chains. I've got this as my outside, then sine of, and then inside of sine is 5x. So derivative of the outside is 3, now it's power of 2. I leave the inside alone. Then I multiply by derivative of the inside. Derivative of sine of 5x is cosine of 5x. And then derivative of 5x is 5. So this is 15 sine squared of 5x, cosine of 5x. Here I want to decide if this is continuous and or differentiable. So continuous, I plug in 1/2, so that would be 4 1/2 squared minus sine of pi 1/2. And then I also want to do it on the other side, -2 times 1/2 plus 1. That's -1 plus 1, which is 0. 1/4, right? 1/2 squared is 1/4. 4 times 1/4 is 1. Sine of pi over 2 is 1. So 1 minus 1 is 0. So yes, the left limit and the right limit are equal. There's an or equal to sign, so that is also the function value. So definitely continuous. And then now I need to check differentiability. So differentiability is the derivative. That would be 8x minus sine of pi x, minus cosine of pi x times pi. And then this would be -2. Now we plug in at 1/2, so this is 8 times 1/2 minus cosine of pi 1/2 times pi. Cosine of pi over 2 is 0, so that goes away, so this is 4. 4 and -2 do not equal each other, so not differentiable. So it is continuous only. Yes, continuous, no differentiable. Alright, dy dx is negative, means y is decreasing, and second derivative is positive, means y is concave up. And the reason I wrote what y is doing is because this is a graph of y, or the f, right? I don't care that that means f prime negative or f prime increasing, because I don't have a graph of f prime, I have a graph of f. So concave up looks like this, so that is this part, and I want the decreasing part, so that is point P. This means increasing. Second derivative, that means concave down. Concave down looks like this. I want the decreasing half of it, so that would be point S. This means decreasing and concave down. So concave down, the decreasing half would be point T. This looks like limit definition of a derivative, so this is just the derivative of tangent. Derivative of tangent is secant squared. Alright, I have dy dx. I want to find the second derivative. So dy dx, I need to take the derivative of this. That's product rule. U is 2x, u prime will just be 2. V is y, so v prime will be dy dx. We're taking it with respect to x. So then 2y plus 2x dy dx. And I can't leave it like that because dy dx, right, is not my answer, but I have dy dx, so I can take dy dx and substitute it in. So this is 2y plus 2x times 2xy, which is 2 times 2 is 4, x times x is x squared, so your answer is E. Graph is decreasing. I'm going to want to make an f prime number line. So first I need to find f prime. This is product rule. So 2x e to the x plus x squared e to the x. This is my f prime. Set it equal to 0. I'm going to factor out, not a 0. I'm going to factor out an x e to the x. That will be 2 plus x. So x equals 0 is 1. E to the x, nothing I do will make e to the x equal to 0. So that's not a factor. And then x equals -2 will make this inside 0. So I'm checking at -2 and at 0. And let's say I plug in 3. That'd be 3, positive, positive, positive. If I plug in -1, that'd be negative. This is positive no matter what. And then positive. If I plug in -3, negative, that would be negative. That's positive no matter what. Negative times negative is positive. So I'm decreasing from -2 to 0. Finding dy dx, so this will be 2x minus 2. So I'm going to do u is -2x, u prime will be -2, v is y, v prime is dy dx. So that will be -2y minus 2x dy dx. This is 6y dy dx equals 0. I'm going to add or move these dy dx's over. So 2x minus 2y equals plus 2x dy dx minus 6y dy dx. Pull out a dy dx. That will leave me with 2x minus 6y. Divide over the 2x minus 6y then. And looks like I can factor out a 2. So x minus y over x minus 3. Oh, that has a y right here. Whew. X minus y, x minus 3y doesn't look like an option. E looks very similar, so let's say I multiply -1 over -1, which keeps it the same, right? If you do it top and bottom, that would be y minus x and 3y minus x, which is the answer. This is f double prime. Point of inflection is when f double prime changes signs. So I'm looking where it's 0, which is 0, -1, and 2. But then 2 has an even power, it will not change signs. This one has odd powers of 1, so it will change signs. So 0 and -1. We are looking at the graph of f. Where does the limit not exist? So definitely does not exist at x equals 2, because the left limit and the right limit are not the same. They're not approaching the same value. Jump discontinuity is, right, when it jumps. That's what's happening here. Removable discontinuity is when you could put a skittle to fix it. So that's at 6. So 6, the limit exists. It's not continuous because the limit is not the same as the function value, but it's a removable because if I just covered up that tiny little point, then it would be continuous. Where is it continuous but not differentiable? Not differentiable means you couldn't get the derivative or the slope at that point, so that would be at x equals 4. Left limit equals right limit equals the function value, but I could not take the derivative because I get a sharp turn there. Here we've got x going to infinity, that's Bobo Bodhi eats dc. This is like 3x over the square root of 4x squared, which is like 3x over 2x, which means eats dc, exponents are the same, it's like a power of 1. So this is 3/2. But with this negative sign, it gets a little tricky because I have 3 negative infinity over square root of 4 negative infinity squared. So I've got 3 times negative infinity. When I square this, it becomes positive. Take the square root, so it's 2. Now it's become positive. That infinity's canceled, but not the negative sign. So this is actually -3/2. Normally the negative on the infinity doesn't matter, but with the square and square root on one denominator or just one of them, then it won't cancel out. Alright, if f is differentiable, so differentiable means f prime on either side, right, this one will be equal to this one, but before it's differentiable, it has to be continuous. That also means this one equals this one at x equals 1. So the limit as I approach 1 from the left and right have to be equal, so that's a of 1 has to be equal to b of 1 squared times 1, or plus 1 plus 1. So this is a equals b plus 2. Now differentiable is about the derivative. So the derivative of ax is a. Derivative of this one will be 2bx plus 1. So then a equals 2b1 plus 1. So a equals 2b plus 1. I'm going to take this and substitute it in for a. So you got 2b plus 1 equals b plus 2. Did I do that right? Yeah. Subtract b over, this is b. Subtract 1 over, this is 1. So b equals 1. A equals 2 times 1 plus 1, which is 3. So then the value of a plus b is 1 plus 3, which is 4. Alright, the next one, point of inflection, I'm going to need to find my second derivative. So first derivative, bring the 6 down. This is 6 fifths, x to the 5th, minus 4 over 4 is just 1, x cubed, plus 15. Need the second derivative, bring the 5 down, that cancels. This is 6x to the 4th, minus 3x squared, 15 will go away. Set this equal to 0. Factor out 3x squared. This is 2x squared minus 1 equals 0. Okay. X equals 0 is this factor. If I set 2x squared minus 1 equal to 0, add 1 over, divide by 2, take the square root. That is x is plus and minus root 1/2. Where does it have a point of inflection? So it should be changing signs over each of these. Remember, this is kind of like the 2x minus 1 and 2. No, I did that wrong last time. Anyway, these are our two values. X equals 0, I know will not change signs because it has an even power. So x equals 1/2 and negative root 1/2. Here, g is the inverse of f. So when I ask for g prime of 4, that is f inverse prime of 3. That means I'm going to use my formula for f inverse, which is 1 over f prime of f inverse of 3. So that's 1 over f prime of f inverse of 3 is the same as saying f of what gives me 3. Or f inverse of 3 is question mark. And we know that g is f inverse, right? It says g is f inverse, so that's the same as g of 3. So that equals 1. So now I'm just doing 1 over f prime of 1. Well, here's f. F prime is 3x squared plus 2x plus 1. F prime of 1 is 3 plus 2 plus 1, which is 6. So the answer is 1 over 6. Here, looking for dy dx, this is my u, this is my v. U prime v plus u v prime. U prime, derivative of x plus 2 is just 1. V stays just v for right now. Plus u, keep it the same. V prime will be 3x to the 5th plus 7 squared times 5x to the 4th, because you're on the inside. Here, I need this in factored form, so I'm going to pull out. The common factor is x to the 5th plus 7, 2 powers of it. So I'm left with 1 power of x to the 5th plus 7. I'm left with an x plus 2 times 3 times 5x to the 4th. And now I just clean it up. This is x to the 5th plus 7. This is 15x to the 4th, which needs to get distributed. 15x to the 5th plus 30x to the 4th. These combine 16x to the 5th plus 30x to the 4th plus 7. And I still have my x to the 5th plus 7 squared. So then that's C. Finding dy dx, we're using implicit differentiation here. This is product rule, like your u and your v. So 1y plus x dy dx equals 1 cosine of y plus x times negative sine of y dy dx plus derivative of e to the xy is e to the xy, but then you need a multiplier on the inside, 1y plus x dy dx using product rule. Oh, this is a nasty one. Okay. Let's get all my non-dy dx's on the left. So that would be y minus cosine of y. I'm going to distribute this. So that's y e to the xy plus x e to the xy dy dx. So then this needs to move over. So minus y e to the xy. I've moved that over, moved that over. Okay. Now I have minus x sine y dy dx plus x e to the xy dy dx, and I need to move this negative x dy dx over. I've moved that one over. Pull out dy dx. And when I pull out the dy dx, I will be left with negative x sine y plus x e to the xy and minus x, and that it will be dy dx. Oh yeah. a long one. Uh-oh. Should that be a minus? My key says it shouldn't. Where's my key? I'll go with this. My key says there's a negative on this one, but you guys let me know if you think so. Here, relative minimum, so I'm going to make my f prime number line. F prime is equal to 0 at 2 and 3. There's nothing that will make e to the x equal to 0, so I'm not worried about that one. 3 has an even power, so that one's not going to flip signs, so I'm not worried about that one so much. So plug in x equals 0, e to the 0 is positive 1, 0 minus 2 is negative, and then this is positive no matter what because it's getting squared, so this is negative. And then 3, that would be positive, positive, positive. So relative minimum at x equals 2. Here I'm finding p prime of 4, so this is going to be chain rule. So derivative of the outside, leave the inside alone. Then do derivative of the inside. Derivative of the inside is g prime, leave the inside alone. Then do derivative of the inside. Derivative of the inside is, the inside is 1/2. Derivative of that would be 1/2 x to the negative 1/2, which is 1 over 2 root x. So times 1 over 2 root x. And now I'm plugging in 4, so this is f prime of g, root 4 is 2, times g prime of 2, times 1 over 2 times 2, so that's just 1/4. G prime of 2, this is a lot of work too. G prime of 2 is 1, g of 2 is 1, so that's f prime of 1. F prime of 1 is 4, so you got 4 times 1/4, which is 1. Use the tangent line to R to approximate 3.1. So I know I'm going to do a tangent line, y minus something equals something times x minus 3. So I'm doing the tangent line at x equals 3. Let's find R of 3. That's just f of g of 3. G of 3 is 4. F of 4 is 4. So this is just 4. Now derivative, got to use chain rule. So that would be f prime of g times g prime of x. Plug in at 3. So this is g of 3 is 4. So this is f prime of 4 times g prime of 3. F prime of 4 is 2. G prime of 3 is 2. This is 4. That's my slope. And then now I'm going to use this tangent line to approximate when x is 3.1. And then add the 4 over. So this is 0.1 times 4, which is 0.4 plus 4. So 4.4 is my approximation. Once you have your tangent line, you literally just plug in the number you're approximating in for your x. Find the average rate of change. So that's going to be t of 3 minus t of 1 over 3 minus 1. So that's over 2. Now I just need to find t of 3, which is f of 3, g of 3 plus 1. F of 3 is 1. G of 3 is 4. Plus 1 is 5. Oops. T of 1 is f of 1, which is 3, times g of 1, which is 2, plus 1, so that's 6 plus 1 is 7. So then this is negative 2 over 1, or negative 2 over 2, which is, negative 2 over 2, which is negative 1. Alright, here I'm looking for second derivative. There's no y's in my equation, so I don't need to do dy dx, right? This is just the first derivative. Derivative of e to the 2x times 2. Derivative of cosine is negative sign, so minus cosine would be plus sign. And then 1 over x is x to the negative 1. This is negative x to the negative 1. Derivative of that will become plus x to the negative 2. That's the first derivative. Now I need to take the second derivative. So I have e to the 2x. I still have that 2, and I'm bringing down another 2. So that would be 4e to the 2x. Derivative of sine is cosine, and that's a negative. Okay. Alright, bring this down. So this is now a negative 2, x to the negative 3. Just bring this down, subtract 1 from the power. And then there's your second derivative. Here we're using quotient rules, so low